Okay, so we're going to just go over identifying domain and range of a relation. Again, not all functions, or I'm sorry, not all relations are functions. So that's why it's not necessarily identifying domain and range of a function. You will be you will need to be able to identify domain and range of any relation, even if it is not a function. So important to look at your key terms here. These were all covered in the 3 videos from yesterday. So the domain is a set of all possible input values. Anything that could possibly go in for X and create a reasonable output is considered part of the domain. Anything that can come out of that relation is considered a part of the range. Now, a set is just a collection of numbers, and it's shown in these braces, usually with commas separating them. Or interval notation is used to also denote domain and range, and it's written with brackets or parentheses. So you might have x is greater than or equal to negative infinity, which is greater than or equal to, I don't know, 17, something like that. Those are just, that's going to be on the recording forever. Something like that. So first off, here is a huge part of what we're doing in Unit 3, understanding the different names for each part of a relation. So X, we've already said X is also called input. Okay? X is also called your input. We also need to know it as the domain. And what we're going to cover tomorrow, or maybe Friday, depending, is X is also known as the independent variable. Okay? Now, with Y, especially for functions, we also need to be able to understand that Y and f of X are the same exact thing. Okay? And then the other ones, they just pair. So if X is input, Y is output. If X is domain, Y is the range. And if X is the independent variable, then Y is the dependent variable. Y is dependent on what X is. Your output depends on your input. Okay? So, find the domain and range of the table above. This was straight from your video from yesterday. So if you watched the videos yesterday, you will be able to do this much more quickly. But your domain is X. Your range is Y. So all we have to do is list our X values. The domain in a table is simply a list of the X values that are given. 0, 3, -3, and 2. Okay? The range is the list of the Y values given. 2, 4, -2, and 4. That's it. That is how you identify the domain and range of a table. Now, we can list values because a table gives specific values. In a video, you saw also how to do domain and range from a graph. Domain and range from a graph, like we're going to do right here, sometimes you can do specific values. Sometimes, and I'm going to show you that, you have to be able to write the domain and range as an interval. So notice our 2 graphs here. These two graphs, they have the same 4 points, okay? But one of them is continuous and the other is not. Can anybody take a guess as to which one is the continuous graph? Top or bottom?
Top.
Okay, so top. So we have 1, 2, 3, 4 points. So can we continue from this point to this point? How would that look if we were going to continue on from one point to the next? What would we do? We would connect them. So who was that? Was that Cheyenne?
Yeah.
If we don't have any space, think about it like a bridge. If I want to get from this point to this point, can I continue on my journey if there's no bridge there?
No.
No. So what we would need is a bridge, and that's what this line down here represents. So it's actually our bottom graph, which is continuous. Our top one is non-continuous, okay? So write the ordered pairs first to get the domain and the range. So if I'm going to write this ordered pair, I go 1 to -3 on the x-axis, and then I go down to -2. Use a different color. This one is I just go over -1, and I don't go up or down anything, so it's 0. My first value is always going to be my x. My second value will always be my y. So I go +1 on the x-axis, and I go up 2 on the y-axis. And then I need another color that can actually show up. There we go. This one is a +3, and then I go up 4. Okay, so there's my ordered pairs. Now all we have to do is exactly like we did in this table, list our specific values. So our domain is going to be a list of the x values, and our range is going to be the set of y values. All we're doing is looking at information and writing it down in a different format for people to understand. Okay? Now, if the graph is continuous, we can't write every single point because look, -3, -2 is still on here. But look, all of these other points on this line are on here. And we could even zoom in more and look at other points. Okay, so there's no way for us to write every single value that's represented by a line on a graph. So that's why we have to be able to use interval notation. Okay? So we noticed our dots were closed here. That means we are going to use brackets. That's like the greater than or equal to. Okay? So our domain goes all the way from -3 all the way up to 4. Or we could say -3 is less than or equal to x, which is less than or equal to 4. Both of those things mean the exact same. Right? Here is our domain. That's any possible value of x. Oh my gosh, except somebody correct me, please. It doesn't go up to 4. It only goes to 3. Now for our range, it can go from here all the way up to here. So this is our range. My range can be equal to -2 all the way up to a +4. So -2 is less than or equal to y, which is less than or equal to 4. Why did I put y for the range? Well, that's because it's along the y-axis, and when we're talking about multiple points or we're talking about a coordinate pair, x is the independent or the input, y is the output, which goes up and down. All right. Here you can see it again. So this is a nonlinear graph, but we're going to still treat it the same. And you can see these diagrams here help flatten the domain and range so you have a better understanding of the domain and range of that graph. So if I have an open dot, that's when we use parentheses, okay? Open dot is parentheses. My open dot is at -3. That means it can't be -3, but it can go almost all the way up to it. And then the range or the domain goes all the way to +1. So -3 is less than x is less than or equal to +1. Now let's change this pen color and I'll do the range. So you can see my range here. And the range can go from 0, because look, right here, it is actually 0 and it's touching. So it can go from 0, I'm sorry, let's do this. We always go from negative, so -4 all the way up to 0. So -4 to 0. And these signs are backwards. So we'll do one more. The domain. Now, here's an interesting one, because look at this. This arrow means that graph continues. It would go all the way on forever. Well, what does that do to our domain? So our domain, the lowest it can be is -5 for some reason. Does anybody know how to write in math goes on forever or infinity? Does anybody remember how to write that symbol? Nobody?
No.
All right, so it looks like a sideways 8. That means goes on forever. And whenever you use an infinity symbol, you always use parentheses, because you can never actually touch infinity, because the numbers just keep getting bigger. So for our range, this is actually not infinity down here. What do you think this is? If the negative numbers are constantly getting larger, that's not infinity. It is actually negative infinity all the way up to a +5. So that would be the domain and range of this, and what would be a function, because it would pass the vertical line test. So here's what I'm asking of you. There are 1, 2, 3 practice problems. I'm going to ask for you to complete those. You can type your answers out and submit them that way. Or you can, if you're able to write in the notes, you can just do a screenshot and submit a screenshot of these 3 practice problems. And that is it for today. I'm going to stop this recording, and then I can take some questions.